For question 1, the first thing that you can do is to actually compare the spectrum from the question with the absorption IR frequency of the functional groups that you can actually find the table from the online resources. So the IR frequency table will actually display various wave number or absorptions associated with the vibrational motion, the stretching or the bending of the bonds in the molecule. So areas that does not have peak shows that photons are not being absorbed at that frequency, indicating that the specific bond at that frequency does not exist in the molecule. So from the question, peaks in specific region are characteristic of specific kinds of bonds, and therefore they can be used to identify whether a specific functional group is present or not. So from the observation, it can be seen that for both sample A and sample B, they do exhibit a strong or broad sort of peak that you can see from 33,000 for the OH zone and the C11O zone for sample A, which has the wavelength around 1,100, and also the CH zone, perhaps they have a wave number around 2,800. Same goes to sample B, which has almost a similar wave number. And for question number 2.
Question 2A, to determine the percentage of ethanol in wine sample, we have to use the values from the table and plot a standard curve graph. From the standard curve graph, we will get an equation. And from the equation, we substitute the values to get the percentage of ethanol in the wine sample, which is 10.5%. As for question 2B, if we prepare a sample of known concentration, this is called the standard, and we measure the peak area and determine the RF. RF is the response factor. This is the ratio between the concentration of a compound being analyzed and the response of the detector to that compound. Then, this process is called calibration. Once we know the RF of a target analyte, we can determine the concentration of that analyte in our sample by running the instrument and getting the peak area.
So for question 3A, I will show you the calculation about how we are going to prepare the standard solution. So the original stock standard solution was 10 mg per ml, and now we convert it to 100 ml, which is 1000 mg. And now we are going to prepare a second stock in order to ease the job by using this formula, which is M1V1 equals to M2V2. So the original stock solution will be put at this M1, and we are going to use the 10 ml pipette in a 100 ml volumetric flask. So the concentration of the second stock solution will be 100 mg per 100 ml. And now we are going to find the volume needed for the standard solution of different concentration, which are 5, 10 and 20 mg per 100 ml. So we also use the same formula, which is M1V1 equals to M2V2 in order to find the volume. And as the same step as the second stock, we use the original second stock concentration, which is 100, and then find the volume equals to 5 concentration in a 100 ml volumetric flask, and the volume needed for this concentration will be 5 ml, which we can obtain this by using a 10 ml pipette. And the volume needed for 10 mg per 100 ml will be 10 ml, which also we can use the 10 ml pipette available. And last,
for question number 3B, we found that there is not accurately presented in the figure of the chromatograph of caffeine standard. The length of the peak is not proportional, as we can see that there is 1.7, 3.4 and 5 cm. Thus is not a proportional peak, and signifying that the standard which should have the specific concentration are not well prepared. If the standard is wrong, the subsequent determination of caffeine content would not be representative of the actual caffeine content found in the sample. Also, from the chromatogram, it does not show the time that should be located in the x-axis and the intensity of the absorbance that located in the y-axis. Thus, we cannot find the concentration of the sample or the standard. In question 3C, we think that there's no caffeine detail on the pad on caffeine content. This is because the caffeine detail on the pad on caffeine content should be lower than 120 ppm, since the peak of the sample is lower than the peak of 100 ppm standard but higher than 50 ppm. Thus, the manufacturer has actually over-reported the caffeine content.